So let's start here, okay? Everybody look here. So this is just a little reference sheet for you for all of the transformation rules that you have definitely already learned. But I want you to look at this g of x here that has the 4 of the 5 transformations in it that we're going to talk about. And we're using A, B, H, and K. I could also teach it as A, B, C, and D. There's some random textbooks that use P, Q, R, and S. My point here is that the letters themselves don't matter. It's where the letters are tells you what they do for the function. Okay, so if you see it somewhere else differently with different letters, it doesn't mean that it's, anything different than this. All right, so then flip this over. Let's talk about our transformations. There's 2 basic kinds, rigid and non-rigid. So the rigid ones just move it around, flip it over. It just changes the position or orientation. The non-rigid ones change the size. It distorts the shape by changing its size. Okay. I don't know how important that vocabulary is. Maybe really not that important for you. Okay. But understanding the rest of it, definitely important. So translations, I feel like y'all are usually pretty good at those because the vertical translation is the very first thing you learn in Algebra 1. So that one you've usually got down because you've done it 5 billion times. But if we are going to translate up and down, then that is vertical. That affects my y. All right, so y is f of x. And if I'm going to shift down, that's f of x minus k. Am I interrupting your conversation? Okay. And then if I'm going to shift up, I f of x plus k. Okay. It affects the y. So I'm going to ask you things like, does it affect x? Does it affect y? When we look at the horizontal ones, that's our left and right. And what do we know about x? X is a what? Liar. X is a liar. So this would be f of x, and negative usually means left, but this would be plus h, and right would be f of x minus h. Okay, because x is a liar. Y does not lie because he's a nice guy. X is a liar. Okay, we're good on that? X is a liar. Then we're going to look at reflections. All right, if I have a point here, let's say that's xy, and I reflect it down here, what changes, the x or the y? The y. The x value stays the same. We change the sign on y. So if we change the sign on y, that is a reflection in the x-axis. So negative f of x. Okay, change the sign on y. If I have a point here that is xy, and I reflect it over here, that would be, would be negative x, y. I changed the sign on x. So a reflection across the y-axis is you change the sign on x, so this would be f of negative x. Okay, we all good with that? That sound familiar? Yes? Okay. So then we have dilations. And there's different ways to talk about these and what exactly is going to be expected of you from your college algebra teacher. Who knows? Because I have no clue who your teacher is, and they all can kind of do their own little thing. But I think we've all talked about them as stretches and compressions. We can also talk about them as dilations, just as a dilation by whatever factor. So you need to know that they're dilations. I think it's more descriptive and probably better to talk about them as stretches and compressions. But I know a lot of you in here last year, we just did dilations because that's what College Board wanted from AP. But again, we need to know that they're called dilations when we change the size and shape, but we also need to be a little bit more specific here. So if I've got a vertical dilation, okay, again, that is changing y, or affecting y, rather. So I'm going to put 2 rows of information in each one of these boxes just to kind of let you know space-wise. So that would look like this, a times f of x, and that's for a stretch or a compression, okay? That a, if you multiply out front, that's going to be a vertical stretch or compression. The value of a is what tells you which one it is. So if the absolute value of a is between 0 and 1, then it's a compression. And it's the absolute value because the negative is the reflection, so we don't care about the sign there. And then the stretch, the absolute value of A would be greater than 1. So we can say that the function will dilate vertically by a factor of the absolute value of A. Then horizontal, that's our x, right? So this would be f of b times x. That would be for a compression or a stretch, right? But x is a what? Liar. So if I have f of 3x, looks like it should be getting bigger, but that's a lie. So for a compression, it's going to be when the absolute value of b is greater than 1. So if I see f of 3x, that would actually be a compression by 1/3. You take the reciprocal. Okay. So then that means a stretch would be when the absolute value of b is between 0 and 1. So the function will dilate horizontally by a factor of 1 over the absolute value of b. Okay, take the reciprocal because x is a liar. So if I'm multiplying by a number, that's a dilation. That's a stretch or a compression. If I'm adding or subtracting, that's a translation. I'm either going left and right or up and down. We good with all that? All right, so even though some of these I think we get right probably every single time, but there's some we get mixed up a lot. And so I'm going to help you through that here. If a transformation affects x, it happens to x before whatever the function type is. So for instance, this is a cubic function, right? Nothing happens to x before it gets cubed. So that -4, all that is, that affects y. Here, this is a square root function. Everything that happens before you take the square root. Now that doesn't mean first like left to right. That means if I was to actually, if I substituted in something for x and actually evaluated this, then I would, do the subtraction, change the sign, then take the square root, and then after I take the square root, I'd multiply it by 2, right? So I think it's going to help if you isolate whatever the quote function, I mean the whole thing's a function, but whatever the parent function part is. So like there's my square root, and then here, this is my x cubed. And then anything inside the box affects x, everything outside the box affects y. And that's going to help you separate it, so hopefully you don't get it all mixed up. So number 1, like I said, fairly simple. Nothing happens to x. All we have is this -4. So that's a vertical translation. Which way do we go? Down 4. So we can just draw an arrow down 4. Okay. Or you can write down 4. Either way, it's fine. Just really you need to know what it is. All right. Now, when I look at number 2, I think it is good to do your transformations from left to right so you don't leave anything off. So we're going to start with that 2. Does that 2 affect x or y? Does it inside the box or outside the box? Outside. The 2 is outside. 2 is outside. If it's outside, it affects y. So that means that is vertical, right? So this would be a vertical what? It is a vertical dilation. That is correct. Is this a stretch or compression? Stretch. Vertical stretch by 2. Vertical dilation by 2 is probably okay too. Like I said, it kind of depends on what your teacher expects and which textbook you're using and those sorts of things. Just know that they're the same thing, okay? All right, so then we come across this negative sign. If I'm multiplying by a negative, that means I have what kind of thing? A reflection. So I have a reflection. Does this negative affect x or y? It affects x because it's inside the box. If I change the sign on x, I reflect across what? Y. Okay. Everything inside the box affects x. So then we come across that 1, and x is a liar. If I'm adding and subtracting, that means I'm going left and right or up and down. Since this is inside, I'm going left or right. Which way am I going? Right. I'm going to go to the right 1. Okay. Any questions about any of that? Easy enough? Okay. Let's just keep on going. All right, so on this one, this is a quadratic. So I'm going to box the squared part here. I start with that negative. Negative is outside the box, so it affects what? Y. So that means this is a reflection across which axis? X. Good. Then I move on to the 1/4. That's inside the box, so it affects X. It's being multiplied, so that means that it is a dilation, right? It's inside, so it's a horizontal. Would this be a stretch or compression? Stretch, because X is a liar. So it's a horizontal stretch by 4. Very good. Are we all good with that? Questions? Ask me questions if I need to clarify anything or you're confused. If you're confused, it's okay. We'll fix it. All right. Then I move on to the 6. That's on the outside. So am I going up or down? Up. Go up 6. All right. When I get to number 4, this is an absolute value function. So I'm going to box everything that goes with the absolute value. So I start with a 3. That's inside, so it affects X, which means it's a horizontal dilation. But more specifically, what is it? A horizontal compression. Good. Compression by what? 1/3. Very good. Because X is a liar. We all go with X being a liar. Yes? What are you doing with your calculator? Why are you being weird? You're just being weird. You're just making me feel like I'm sketchy over there, like you're doing something. All right. It's okay. Everybody's weird. I didn't mean that as an insult. I'm weird too. All right. 5. I'm going, what does this mean I'm doing? Left 5. Good. And then the 2, I'm doing what? Down 2. Okay. Everybody okay with that? Yes? Okay. All right. So here I'm going to box the squared. That 1/2, is that horizontal or vertical? Vertical. And it would be a vertical what? Compression by 1/2. Because X doesn't, or Y does not lie, because he's a nice guy. And then the 6 means I do what? Right 6. Good. Not up. No, not up. All right, so all the ones we've done so far, we can identify. It's a quadratic, it's a cubic, it's an absolute value, whatever. Now we're on to the generic functions, okay? Because you could totally be asked stuff like this too. So it really sometimes makes it easier. It looks like it's more difficult, but like I don't know exactly what kind of function it is. But the part I would box here would be the f of whatever, okay? So that's f of 4x. Still, everything inside affects x, everything outside affects y. So I start with the negative. That would be a reflection across x-axis. Very good, because it changes the sign on y. Then I get to the 4. Inside and being multiplied, so that makes it a horizontal compression by 1/4. Very good. Okay. And then the 3 means we do what? Up 3. Any questions? Okay, we're going to do all these because I have a feeling there's a few people that might have some questions or some confusion, but won't say anything. So, and it won't kill us all to do these. On 7, this is what I would box. And I have 4 transformations to write out. Got the negative, which is a reflection across X. Good. Yes. You can say over. Yes. Across, over. And on the other part, it says in, which sounds weird, but that's correct too. But yeah, over is fine. Over, across, any kind of word like that, you're good. All right. So then the 4, that's going to be a vertical what? Stretch by 5, by 4. I don't know where 5 was coming from. By 4. The 1 says we're doing what? Left 1. The 2 says we're going up 2. Okay. We're going to be transformation experts? Yes. Okay. 8 should be super simple because there's only 2 little things, and I think we're usually pretty good at these. 5 says I'm going which way? Right 5, and then down 1. Okay. It does not matter what order you put them in. I think it's a good idea to go from left to right so you don't forget anything, but no, the order doesn't really matter. The order you would do them in if you're graphing matters, but not just writing them down. All right. This is what we're boxing here, right? So I start with the negative. That is going to be a reflection across what? Y-axis. Good, because that's on the inside. The 1/3, that's on the inside, so that makes it a horizontal something. It would be a horizontal what? Stretch. Very good. Stretch by 3 because X is a liar. The 4 says we do what? Right 4. 7 says we do what? Up 7. Everybody good on those? Any questions? All right, you do number 10 while I hand out the assignments. No, it's totally fine. But you know what it looks like? It looks like you're like trying to watch your phone behind it or something, or like trying to, trying to sneak a video of something. Like, not that I think you're doing that, but you know what I mean? It just looks weird from up there. It's fine. You can hold it. If it makes you pay attention, I don't care. Yes, ma'am. Okay.
So when I first did it, I did it because I thought this was what you bought.
No, it's the whole function. Well, I know it's not touching the X, but it all happens before whatever the function actually is. And so that's why you're doing that whole thing there. Yes. Yes, let's finish this real quick and then you can go. All right. So just to clarify, because this was a good question, I know that this is not touching X. We're not just boxing this. We're boxing the whole thing here because all of this happens before you square it or take the square root or whatever the function actually is. So, but here, this is all I would box because it's the F of part there. That negative would be a reflection across which axis? X. Okay. Then that 3/2 would be a vertical what? Stretch. Be careful there. Just because you see a fraction doesn't mean it's a compression because that's greater than 1, right? Vertical stretch by 3/2. There we go. Left 3, down 8. Oops. That was weird. Oh my God. Okay. Left 3, down 8. Any questions at all? Okay. Y'all got tons of time to work. You could probably finish this. Okay? So work with each other. Ask me questions if you get confused about something. Make good use of your time.